Guys, today we are here to present you about the goal points in the planets project, that's project 61B. I am Tushar Jain and my partner Kenan Jiang, who is currently recording this video. And the modifications that we made in our project is basically a revolution.
So what we did in normal project is we create a solar system right here, and there's Sun and Mercury, Venus, Earth, and Mars. They kind of like doing rounds around the Sun. But what we add to this program is that we add a specific area showing how many rounds each planet has done revolving the Sun.
So as Kenan mentioned, we created a display where we in real time update the number of revolutions each planet has taken. And how we do that is basically imagine that there is a Cartesian plane over here which represents our universe, with the Sun being in the center, with Mercury following, then Venus, then Earth, and then Mars. We know that the maximum and minimum points of this Cartesian plane is the radius, the positive radius, negative radius, and the negative radius. Okay. So how we did this earlier, when the first thought that came into our mind was, whenever the y position of the planet becomes 0, the planet completes one revolution. On implementing that, we got a really vague figure where the revolutions kept updating till thousands. However, that was not the case. So what we realized was that a planet actually never crosses the y at 0th position. Why? Because the the YY pause of the planet keeps on updating, and it is rarely that it exactly equals to 0. However, how we overcame this problem was, we know that this area is the negative y-axis and this is the positive y-axis. So another way to think about is, whenever the planet crosses this axis, its old YY pause, old y position is negative, and its new y position is positive. And that is how we got the logic behind each and every updation of the revolution, whenever the y position of the planet changed from negative to positive, it completed one revolution.
So we already covered the logics behind our modification. Now I'm going to talk about the modifications we did to the planet extreme file and the embody extreme file. So for planet extreme file, we first add a new instance variable called rounds, and we also added that into the constructor, and we set it to 0 for each newborn planet. And the most important change we made to the planet extreme is we did something in the update method, in which we compare the old y position to 0 and the new y position to 0, and we write it in an if statement. If the old position is less than 0 and the new position is larger than 0, we add 1 to the rounds. So that's what we did to the planet extreme file. And for embody extreme file, we used std_draw to draw the information we want to print out here. So since we are printing it on the left of the screen, we used std_draw text left, and after that we put like the position, the location we wanted on the screen, and then we print like the planet's name, and also we have to get the rounds, so which is the integer. So I used the integer to string to get the rounds printed out, and we did all those std_draw stuff in the places where we draw the image of each planet in a normal project.
Okay guys, so this project of ours is also useful for students studying astronomy, as they can actually calculate the number of revolutions a planet takes in a given amount of time. And so yeah, that's it, and now we'll show you the output of our final project, and thank you.